Hello. In this video I want to develop a more natural notation for complex numbers. So you'll recall that a complex number is an ordered pair of real numbers. And so we write a complex number as z is a+b. Right. Now, in order for us to develop this more intuitive notation for complex numbers, we first have to realize that in fact every real number is also a complex number. And that is true in the following sense. So we take some real number a, and with this real number we associate a complex number. And the complex number we take to represent this real number a is the complex number with real part a and imaginary part 0. So if we then have two real numbers, a and b, and we look at the complex numbers associated with them, we note the following. So if we add these two complex numbers, using the definition of complex addition, we just get a plus b 0. And this is the complex number that we associate with the real number a plus b. Okay? And if we do multiplication, well, what are we going to get? Well, it's going to be ab plus 0 times 0, and then, well, actually minus 0 plus 0, and then we have a times 0 plus 0 times b, so that gives us ab 0. And again we note that this complex number we have here, ab 0, is that complex number that we associated with the real number ab. Now what's the point of all of this? Well, firstly note that if you have two real numbers, a and b, then the associated complex numbers, a0 and b0, will be equal precisely when a and b are equal. So in other words, with each real number we're associating exactly one complex number. And these two equations here, what do they tell us? Well, what they tell us is that if we take real numbers a and b, then addition and multiplication, right? These things are the same whether we do it in R and then go and associate a complex number with the answer, or whether we associate the complex numbers with a and b and then do the operations in C, in the complex numbers. So taking all this together, we see that we can think of R, the set of real numbers, as a subset of the set of complex numbers. So in other words, every real number we can think of also as a complex number. And based on the way in which we associate a real number with a complex number, in other words, remember we said we take the real number a and we send it to the complex number a0, right? We call a complex number z real if its imaginary part is 0. So in other words, precisely when z is of the form a0 for some real number a. Okay. Now, how does this help us to develop a nice notation for complex numbers? Well, let's look at two specific complex numbers. Right, we've got the complex number 1, 0 here, and remember, this is the complex number we associate with the real number 1 in R. And then we look at this guy here, and we call it I. It's a very special one, and it's denoted 0, 1. So, a few things to note. If we look at the complex number I, what is I squared? Well, it's 0, 1 times 0, 1. So if we just apply the definition of complex multiplication, so we're going to have 0 times 0 gives us 0 minus 1 times 1, and we're going to have 0 times 1 plus 1 times 0, and that gives us the complex number minus 1, 0. Now remember, what we've got here, minus 1, 1, that is the complex number we associate with the real number minus 1. So in fact, we can think of I squared as being minus 1. Right? That should be strange to you, right? Because this can't happen if we're dealing with real numbers only. Right? Now, let's now look at this one, 1, 0. So, if we take any complex number z, a+b, and we multiply it with 1, 0, what are we going to get? Well, it's the complex number a+b times 1, 0. So that's a times 1 minus b times 0. And we're going to have a times 0 plus b times 1. So all that this gives us is ab. So z. Right, so we see that multiplying any complex number by this complex number 1, 0, which again, remember, is the complex number we associate with the real number 1, right, it has no effect. Right? When multiplying complex numbers by the complex number 1, 0, it is the same as when multiplying a real number by the real number 1. Right? It doesn't do anything. Now, let's see. If we now take a complex number z, then, right, so this is ab, right, then based on what we see here, right, so this is going to be, we can write it as a0 times this complex number 1, 0 plus b0 times the complex number I. And now remember, this is the complex number we associate with the real number a. That is the complex number we associate with the real number 1. And this is the complex number we associate with the real number b. Right. So, exactly because we identify the real numbers ab with the complex numbers a0, b0, right, we now adopt this notation. So, from this equation here, right, we get this notation. Right? So instead of writing a0, right, we just write a, because a0 is the complex number we get from the real number a. And we don't write this 1, 0 here, we just write 1 and therefore omit it, because 1, 0 is the complex number we associate with the real number 1. Right? And same thing here, we don't write b0 anymore, we just write b, because b0 is the complex number we associate with the real number b. Right. So we can now write every complex number in this form. Z is a plus bi. Of course here a and b are real numbers. Okay. So a couple of things to note. Right? This is a nice notation. In particular, so if our complex number is real, so in other words its imaginary part is 0, we just write z is equal to a instead of z is equal to a plus 0I. Right? And likewise, if the real part is 0, right, we don't write z is 0 plus bi, we just write z is bi. And if we have, for instance, the complex number with imaginary part minus 2, right, we don't write z is 3 plus minus 2i, we just write z is 3 minus 2i. Okay. Now, this is called the standard form for a complex number z. This z is a plus bi notation, right? Now, what does addition and multiplication look like in this notation? Well, if we add, right? Remember, we just add the real parts and we add the imaginary parts, right? So that's quite simple. Multiplication is not very nice, right? You don't need to remember this slightly complicated definition for multiplication of complex numbers, right? Because remember, right, if we write it like that, right? And now remember, each of the terms here is a complex number in its own right, right? So the a there is a plus 0I, and the b there is 0 plus bi, right? And we've proven all the arithmetic rules for complex numbers, right? So multiplying into brackets, distributive laws, associative laws, all those things. So we can now apply that here, and that means basically multiplying out these two terms, just like you would if it were real numbers here, right? So in other words, we can write it as a times c plus ADI plus BCI plus BDI squared. And now remember, I squared is minus 1, minus BD. So what we end up with, if we just group the real and imaginary terms together, is AC minus BD plus AD plus BCI, right? And that agrees with our definition of complex multiplication, right? But because of this nice notation for complex numbers and the fact that we've proven all the arithmetic rules for complex addition and multiplication, right, we can treat this product in the same way as we treated products of real numbers, right, where we have an AB times A plus B times C plus D. Okay.